see that you can at least do your assignment due on Thursday. Okay, and I think I've given you enough context there that you, without even knowing how the whole thing is working, you can, change the.
What PowerPoint was this? Is this the GIPC-RMI PowerPoint?
Yeah. Lights are back, right? Okay, and we'll do that part, the one that you're supposed to change, and then we'll just see what else I can do today and on Thursday, and maybe also after Thanksgiving. So what we saw was that there is an RPC port that finally goes and sends data to an object port. We know that object port, once it sends it to object port, your serializers take over. And we want to kind of know what is fed into the object port. And you guys saw last time what was fed also. You saw that serializable call gets fed and a return value gets taken out. And so we saw that certain objects that are created by GIPC just get serialized and sent by the object port. And we saw that things go between ports through trappers. There can be a chain of trappers in general. And when we went from object port to byte buffer port, the trappers did not talk to each other. They were just independent channels. But now these trappers talk to each other. They share some data structures. Okay? And why do they share data structures? For two reasons. One of which is if you're making a function call, or if you guys in your assignment have to make even a procedure call, or we're going to make the sender wait. Okay? If the sender is going to wait, they're going to unwait or unblock only when a message comes in. Okay? So somehow they have to talk to each other for that reason. And do you guys know, for those of you who started implementing the next assignment, what exact data structure here, what object is the one that is used for synchronizing, that is shared between the two, and what's the class of the object? Call is what you send across, right? Serializable call is the object that gets sent across. We want to make sure that the serializable call waits till a return value comes in. So some object that is shared by the send trapper and the receive trapper is going to help with coordination, right?
Is that the RPC return value?
That's just a value that comes back. Return value comes back just as a new value.
Yeah. How about the coordinating?
Yeah.
Middle layer shifter?
Sorry?
You're talking about the middle block.
Yeah, I'm talking about something that is going to make this guy block. So something that can be used by this guy to block and by this guy to unblock the block guy.
Some form of blocking queue.
Yeah, there's a queue, right? And that queue is replaced in your system by something else. You guys use receive calls now. And the object that's keeping the queue and that's going to go and do the receives, that object is which one? The receiver and sender both need to share it. So after you send the call is not complete till it is unblocked.
Right, so a response has to happen.
Right, so the object it's just a name. I mean, I thought you might have said the send call completer. Okay. So it's actually, it's the other half, but it is kept by both the receiver and the sender, right? So the send call completer is the one that can either go to a queue or go and do a receive or whatever. Okay, so that's the object. And so there's some coordination between, at the receiving side, at the calling side, there is some coordination between the send trapper and the receive trapper. And there has to be some coordination between the client and server also, right? That the expected format arrives, the return values that it expects is the return value that it sends. Okay, so there's coordination both between sender and receiver at the local side, and between the sender and receivers at the two sides. Okay, that the send call that is sent from here is the one that is expected at the other end, and vice versa. Okay, so that's kind of stuff you saw. That well, you need to worry about both of these things in your current assignment. Okay, coordinating these two guys and coordinating the sender and the end receiver. Okay, and so the send call completer has many implementations. The duplex one has, and this is what. So what are these methods? Yeah. So what are these? What are each of these methods in the send call completer doing? So return value of remote method call is doing what? So somebody calls it. Who calls it?
The receiver, the caller.
The caller is going to call it after sending the serializable call. Is going to say, okay, let me call return value of method object, and it's going to have some value returned. In the case of procedure, that will be just now. Okay, and what are these two methods then? So that's method. This is function. Sorry.
Analogous to the other different kinds of remote implementations you could do.
Right. So a method call is either.
Function or secure.
Okay, so we can control each separately, which is what happens in GIPC, that we block here, we don't block here. Okay, so the remote method call is just going and dispatching it to one or the other. And this is what you guys have to worry about when you go and decide what you're going to do, how you're going to get the value back. So your implementation, like my implementation, is going to send a serializable call across. Okay, you're not mucking around with that. The question is what happens after the call is made. Okay, and you call this method, and you will. I think I asked you guys to do a different factory for a send call completer. Is that what I asked you to do?
Yes.
Okay, so that's what I do. And then what's this method going to be then?
That gets called by the CALLEE.
By the, okay, this is very interesting. The callee or the receiver at the local end, right? At the local end, somebody has to unblock this guy, right? These two guys are blocking.
Yeah.
So then that work is on the remote end. So
No, the blocking is done at the local end. Yes, this will get a message and respond to something that happens at the remote end.
So process return value is responsible for unblocking.
Yes,
So
at the sending end. Right?
But send call completer has all these interfaces, all these methods.
And send call completer is used by both the receive trapper and the send trapper.
And send trapper, right? But we have to make our own send call completer.
Yes, I think so.
Duplex send call completer. One thing is duplex send call completer doesn't have all four methods. It only has two.
Oh, it must be inheriting otherwise.
What do you mean?
It's implementing this interface. It's got to have. Java won't let the duplex send call completer not have all four methods.
No, seriously, I just made a class implements duplex send call completer, and the only unimplemented methods it forced me to have are to return value of method, remote method call, and maybe process return value.
So the others are, okay, so you have to go in subclass. The others are, these are not all public methods then.
And they might be implemented higher up in the.
These are, so remote method call guy goes and calls these two guys, so these are not, so this, I shouldn't say send call completer, okay?
Yeah.
I should say that this
Send
is,
call completer is an interface. that
yeah.
doesn't-
So these, some of them are protected methods that are inherited. So I don't ask you guys to subclass of my,
No, you asked us to make our.
no, I think I say subclass.
Yeah, I think you changed it later to say subclass.
I did, right?
No, you said.
I said set.
Provide an alternate implementation of this interface of duplex send call completer.
I know that, there's some qualifications.
Says derived from
Yeah. No, you're welcome to go and, do it all. You can just go and do the dispatching yourself too. I'm just saying inherit from me so that you just go and do this or the other. Maybe I should make it a public method. Maybe that will be beneficial. Because I also got confused. I thought I'd made them public. Okay? Okay. Okay, so basically from the send trapper and the receive trapper point of view, the two important methods are this one and this one. These are the two methods. The process return value and,
Yeah, the first and the last.
because that's just dispatching.
Maybe process.
Okay, yeah, okay. So that's another. Maybe process return value is basically saying that whatever you get could either be a return value or it could be a serializable call itself. So that's just a method that goes and checks whether what it got was a return value or not. So it returns true. Okay.
Yes.
Okay. So that's that. So I should really say here a duplex sent call completer, and these are both public and non-public methods. Okay. Questions?
So the first three method is called by the sender, and then the sender block
Maybe blocks.
a maybe block. So the receiver called the process return value to send back a return value to the sender.
Yeah. Right. And actually, the receiver calls maybe process return value, okay, which does all the things about checking if it's a sent call, it's a received call, it's a received call or return value, and depending on which one of these it is, it goes and calls process return value. So it just says maybe process return value and maybe process value, and it sure calls process return value. So you don't have to worry about that dispatching. So the two dispatchings that happen, you don't have to worry about. One dispatching happens in the remote method call, because it may be one or the other, and the other dispatching happens when a return value comes in. When something comes in and you have to go and figure out whether it's a return value or a serializable call.
So the three we have to deal with are the bottom three in the interface.
Actually, you just have to, yes, absolutely. Which are not, the three you have to deal with are not in the interface.
Right, are in the interface. Okay, I got it.
So we just have to deal with the first and last one.
No. We don't have to deal with the first one because it dispatches. We have to deal with the bottom three because they don't dispatch. They actually do the blocking on blocking.
Okay. Okay.
Why am I still seeing a mobile version of the handler in the last one? I keep refreshing but it keeps showing the same.
Oh.
Clear your cache.
Okay.
Clear your cache.
So the procedure call, return value of remote procedure call, just non-blocking, simply returns in the current implementation, and this blocks a return value. Okay. Your implementation in the second part will make it block, but return just null. Okay.
Blocks, and then when it gets the reply, returns null.
Yeah, because a procedure call is just going to get an acknowledgement, right?
So all right. So I guess it's just you know for sure that it finished. Okay.
And for some reason, I just allowed an object to be returned there. Because the method invocation had an object. For some reason, I just didn't do a void there. Okay. So,
And on the previous slide, I think that doesn't that get executed in the selecting thread too?
so let's go and see all these things. Okay, this is going to be a very interesting issue. Okay, I hope you guys like this because I can't even tell you how much time I spent on this slide. And I'd like to create it automatically. So we'll talk about that in a second. So we have a remote object with some method that returns value t. Okay, let's assume we've got now a function call. Okay, so we're going to call this method through a proxy. Okay, somebody's going to call m on the proxy. Okay, what's the next step? What's the next step that's going to happen before we go to an object port? Before we go to a send trapper? So we're going to ultimately, the message is going to go through the send trapper, right? A call was made in the proxy, an object has to be sent to the send trapper.
We have to serialize it first.
So we have to, the technical term, serialize it rather than, okay? So, and I put dashed lines here saying this doesn't happen directly. It happens through some intermediate objects that I'm not talking about right now, okay? So we get the object, and then we go and send it to the send trapper, okay? In whatever thread the proxy is executing, okay? And what happens after this now? Send trapper gets it, what should it do next?
It gets into the next send trapper.
So it can, okay, so that whole chain and what else then? Finally, what will happen to it?
It'll get put in the send on port.
And it'll just go, right? So send went and put it on the queue, and then what should send do after this?
Block on.
So remote function call is blocking. So it goes and says through process, maybe process return value and so forth. It goes and says return value of remote function call. Sorry, through remote method call, it goes and says remote value of function. Okay. And it's blocked. That thread is blocked. Not my selector thread. Okay, this guy went and put it in this queue. The selector thread went and got, read the queue. So these are two different threads we're talking about. You better not be executing your proxy call in the selector thread. Is that what the problem is? Is that the deadlock problem you had? Did you figure out what your deadlock problem was?
So I think it still happens. I think send call completer gets executed in the selector thread.
But if it'll get executed in selector thread only if you made this call in the selector thread. You should not be making proxy calls in the selector thread. Remember the launcher has a create UI method and a post connect something method. Do post connect operations. Yes, sync operations. That is what happens in a separate thread. Otherwise, it will happen in the connection thread. Okay, so that is what you want to avoid. Sorry? Do post connect operations calls create UI. There's a method called do post connect operations. That is the one that calls create UI. Okay. Create UI doesn't seem to be a nice method name because you may or may not be creating UI. If you are creating UI, you do that. Otherwise, you do the longer name. That was my trick.
So does the launcher then make the current thread that's calling it the selecting thread? Or is that?
No. Launcher will create a new thread.
Okay.
After all the connects have happened, the launcher goes and then creates a thread to go in to do the do post connect operations. Okay. Okay. Now this guy is going to go in my implementation. Go to a queue and just sync it. Not in your implementation. Right? Okay. Now the call goes to the other end. Through various things, it goes to the receive trapper. The receive trapper, what does it do? Or what should it do? You haven't worried about this so far. Or maybe you do have to worry in the second part, I think. Or even in the first part? Maybe.
You mean the receive invoker?
Yeah.
It's the second part of the second part.
Yeah. So what should this guy do now? This is what has to be executed ultimately.
So it
So
marshals to get it back.
So okay. So it's got to demarshal. What does demarshal really mean?
You deserialize the serializable call.
No, it's already been okay. So it's the object has been. It came as a byte buffer. It became a received call.
Okay.
So we've already deserialized it. Now we have to unmarshal it. Right? We have to look at its fields.
Create a method invocation for it in the
Invoke method, and hopefully, look at the type names, and if the method doesn't exist, not just return null. So that what should happen?
So it does. It figures out what the target object is,
And just calls
does
it.
reflection on it to get the method out of it, fill in the parameters, and grab the return type after the invocation, or grab the return object after the invocation.
And then what does it do with the return object?
Send it back.
Okay. Any threads involved here? Any new threads involved here?
I'm doing synchronous send, so that doesn't have to be another thread.
So we're going to invoke this method.
Well, we'll still have the selector thread on the receiving end so that more messages can come in while we're invoking this.
Is that just for throughput?
Well, yeah, and you don't want to go up the hill either. Because what if the method you call takes a long time to execute?
And then you're not responsive.
Exactly.
How long can it execute?
It can potentially go on forever if someone silly made an infinite loop.
So in your case, when you register this method, when you call register method, what does it do? It goes in. When you register, you go and send your proxy back. You send your proxy, right? And does it ever call back?
Oh, it can.
So to call back, it needs to select, the selected thread needs to send the value. Selected thread is waiting. Okay, so if this guy goes and calls back, we'll see the deadlock
Oh yeah,
situation.
because it'll call, like, if you pass it a remote object as a parameter and then tries to invoke some method on that, then it's deadlocked waiting on its syndicate. Okay. I can see
It's made this guy wait,
Yeah.
you know, and so, okay, we'll see that. So receive trapper goes and doesn't do the whole job itself. Just as there's a send call completer, there's a received call invoker. Okay, which is why you guys were getting confused. You were thinking if send call completer is the received call invoker at the remote side. No, these are two different objects. The received call invoker will go and get the message received. It's just a listener to that send trapper, and it's the one. And so receive will return after that. Okay, that thread returns, and now the received call invoker in another thread calls T at M. Okay,
We have to make our own receipt call invokers.
or subclass. And it returns, and what's it going to do? It's now going to go and do handle function return. So this is the thing. I go and have this method that you guys can then go and override, I think. Okay? So it'll do handle function return, which is going to do what? It's going to send a call to the send trapper and send a return value to the send trapper, and then the return value is going to come back here. Right? And it's going to go to the receive and the receive trapper, which is going to say maybe process return value or do something else or invoke the call. And it goes and calls process return value in the send call completer, which does a put. The selection thread is released. The other thread is released, complete.
Wait, the selecting thread shouldn't have been blocked there, should it?
No, that's release meaning it just goes.
Okay.
It does this next job.
All right.
And what I mean is that this put is not a blocking function.
Right.
This is very important, by the way. Huh? This is a producer-consumer. This is a bounded buffer. Bounded buffers can make the producer and the consumer block. You better make sure that this guy never gets, the buffer is never full. Okay? If it is full, you don't. I mean, there's two ways to do it. So this happens in interrupt processing in operating systems also. That if I'm receiving characters from the terminal driver, that, you know, when you do get C and put C, you are actually you are actually consuming. You are either a producer or a consumer. When you're doing put C, you're a producer. When you're doing get C, you're a consumer. It's okay for you guys to block, but the interrupt routine should never really block. Okay, we just have to hope that the buffers don't get full, and if they get full, you just drop the message and say, you know, sorry, something bad happened because I'm not going to make my selection thread block. Okay. Now you see why it took me so long to make this. Okay, firstly these slides, these things, and secondly, how much detail to put in. You know, there was a dash line here. I was putting more detail than was needed. I first didn't have. I had one version without the receive trapper. So by the way, I mean, you know, you just have to take my word, right? That GIPC works this way. And I had to.
I mean, what I've seen.
It's probably right.
It works at least somewhat like that.
But wouldn't it be nice if I just wrote GIPC and these slides would get generated automatically? Is that so crazy?
No, but they have help doc stuff that, that automatically generate.
Can this slide be generated with help doc?
I mean, it might not be able to generate blocks, but it'll generate.
No, I want this slide. I want this graphical slide with these animations.
You want like a UML diagram?
I want this.
I mean, I don't know if it'll generate.
Don't give me what I don't want.
Visual Studio will do a two-way UML diagram for you.
Just because it has blocks and arrows doesn't mean that everything, you know, just like saying, oh, you want this English sentence paragraph, I'll give you that English paragraph. You know, I want this kind of this. You want this language.
You could get something like this, I think, but you'd have arrows all over the place.
Okay, then I need fill. How would I get something with too many arrows? How would I get that from GIPC?
Because it depends. Like you have your marshalling calls, or your the ones that call other functions depending waiting on some some condition.
Right.
So you have to draw both of those arrows, and then so instead of it like sending from one, so like the sync call completer, instead of sending to return value of remote method call, it'll have to go to all three of them, and then so it'll loop back on itself.
So there's a system called Jive. You know, it's very interesting. When I didn't know this problem, there was a guy who was a faculty member here who went to Stony Brook, and he was here for a conference, which I actually also, both of us had papers there. And he told me about a system called Jive, which actually tracks, it's a debugger that tracks method calls. And it can generate diagrams like this. So I ran Jive on an object editor. I waited for 1 week, it didn't return back, you know. So it gets too many calls. But what I can do with my tracer bus, so I want to,
Get really close to this.
and then with the filtering that I have in tracer bus, and if I can get an automatic layout tool to support this, I really hope to make that some summer when I can have the time, that I want to generate something like this. I've already found a way to go and write to PowerPoint from a program. So I can actually write to OpenOffice, and it has an API, and I can even just draw diagrams. So I really think that, you know, I just waste too much time first coding and then writing this down. It would be nice. The layout will be the tricky part, but I've got a graph visualizer, and maybe you can tweak that to go and show something like this. But anyway, that would be good, because this takes forever. Okay, so that's the function call thing. For procedure calls, what happens? Proxy comes in, you invoke the marshal call thing, you send, and then the call goes across, and then send says, well, I don't know, I'll just call return value of remote procedure call. And if you have overridden it, you can make it block, and if you haven't done it, that does nothing. It just returns, and then everything happens like before. The call comes in, and call gets called, and that's it. Okay, let's talk about deadlock. Okay, and I've got a different kind of diagram right now. So here comes a call at the server end. The selection thread goes and calls select to go and process the call, right? And that goes, and then it goes and says, okay, I'm off from the select. The same thread is now executing message received, right, in the RPC message receiver. And that goes and calls this method. This method goes and calls a proxy method back to the site. The call goes across, and this guy goes and waits for the return value. Okay? And that return value is not going to be processed till the selection thread unblocks, till it makes another select call. Okay? So you need another thread. Okay? And whether you get the thread or not depends on a factory. So one of the things I ask you to do in part 2 is to change the factory and create this deadlock situation to see whether it occurs or not. Okay? So return value comes in. Return value comes in from the other end, but there's nobody to receive it. Okay, so that's a deadlock situation.
Well, there is someone to receive it. He's just locked.
Yeah. There's no one ready to receive it. So there is an asynchronous invoker. There's a synchronous invoker and an asynchronous invoker. If you really know you're not going to do this thing, you don't want the context switching of threads, you can just put the factory and say, I want the synchronous guy. Otherwise, you can get the asynchronous invoker. Okay, so the asynchronous invoker, the call comes in, the selection thread calls select, message received, and I've got something wrong here. So message received should really go and, I don't think I create the thread after this is called. Okay, I create the thread before. Okay, and I have to change this diagram. See, this is where you need my other system. So now the invoker will go and call. So I think I changed my design, and this may be a little older slide. And this will go and call the proxy method. So basically, the proxy method has to be called in a separate thread. That's the key, and I have to correct this diagram. Okay. And so it is this GIPC invoker that's blocking. What you could have done in your remote object is invoke this method in a thread. That is what I used to do before I added this thing. And I just went to use the same diagram, I think, to go ahead and put GIPC invoker here. Okay, so that's something else you can do. If I'm not doing it, the system's not doing it. And by the way, do you guys know what happens in RMI when you make a call? You make 2 calls to a server object. Each call gets invoked in the same thread. So in here, there's only one invoker for all methods, incoming methods in GIPC. You could have a separate thread for each invoker. Okay, but there's only one thread. And I don't remember, and I forget whether RMI, is it the same thread or is it different threads? It's got to be a thread, or is it the selection? I'm pretty sure it is not there because you guys didn't deadlock. It's pretty sure they don't have an NIO implementation, so I don't even know what's happening there. Maybe so maybe each maybe there are multiple threads to receive messages also for all you know. Okay, but this is an important issue, that which method is invoking, which thread is invoking an incoming method. Okay. So factory determines if asynchronous method invoker is created or not. Okay, and that's the factory that I ask you guys to play around with. Okay, so I think I've covered everything you need for your next assignment. Questions? Should I have in my calls and return values, should there have been some IDs there? Call ID, return value. I mean, should there be a call IDs there? And another way to ask this question is, how many such queues should I have? Or do I really need a queue, or can I have a little variable that you can wait on? Just a global variable. The last call.
I would put an ID in.
Just to be on the safe side.
So like, you could argue that the target object, method, and parameters, if they're the same, then it should return the same value. So there's no need for an ID. But what if that function depends on some other factor that isn't encapsulated in that information?
No. So what would I do with the ID exactly? Tell me. So when I send my call, I said this is call number 10.
Right, and so when you send it,
You say this is return value for call number 10.
right.
I mean, I cannot tell you how long I thought about doing this. It's so easy to do, right?
Yeah,
And I said, no, I want to reason this out. Do I really need it or not? And we might find out that I really needed it today. Okay? So just to be on the safe side, I could have sent it, but I really want to reason things out. Yeah.
It could get dangerous because I think we'll sort of client. So the client calls to the server calls back to the client, then the client has to call back to the server, then it could get dangerous.
It can, but
But each call would have its own ID.
Without the ID.
Well, yeah, that's what.
But you can alleviate that if you, right now in the assignment, we're waiting, the first thread that blocks is the first one to get unblocked, but if you do it in a stack fashion, it'll pop the return value from the other.
Yeah.
can a thread, so let's look at some invariants. Firstly, in RMI, they don't have this problem. Huh? From what Asad told us last time, or a long time ago, that you cannot have 2 outstanding calls to a server. Okay, you will wait till the first call completes, and then you will send another call. Okay, so they don't need an ID based on what we know of the semantics. Okay, here we are trying to be very, we are allowing multiple calls to happen. So if there are 2 different. Okay, so how can you have? Let's talk of function. I mean, return values make no sense of procedures anyway, right? So let's talk of functions. Can there be more than one outstanding call, function call, from a client side to a server side?
Yeah.
In GIPC?
Situation like you just said. So I would make a remote call on. I'm the server. The client makes a remote call on me. I make a call on the client, and then to serve that request, it makes a call on me.
Okay, so that's fine. So it has made 2 calls. Was the first call blocking?
Yes, because it needs to return value.
Okay, so how many different threads were involved here then?
Well, it depends on how you implemented your invoker.
So at the client end, there will be more than one thread, right?
There has to be.
Otherwise, you can't.
Right.
So a particular thread can have only one outstanding call, blocking call. We know that invariant, right? Now, if you have more than one thread here, can the return values come in the opposite order? You're saying they can?
Well,
So
if it's coming back, it's gonna, if you,
that's it.
if your call from back, this, the final call to server, the second call returns, it's like popping off the stack. So if you give the return value to the last person that made the call, the last thread that made that call.
Yeah. So what happened? I made a call. Let's get this right. Maybe you guys are onto something, maybe not. So you called a method from here to the server. The server made a call back.
Right.
And you're a thread T, okay, and you are blocked here. That server made a call back here, which made a call again.
Yes, back to the server.
That's like basically two threads making calls here, right?
Yes, there are two threads, each making a call on the server. But the second thread that made the call needs its answer back first.
Right.
From that site.
Yeah, because it needs its request from the server. It gets to pop off. It sends its response back to the server, and then it sends its response back to the client.
So if you implement your return value queue.
Okay, so here's the deal, guys. Here's the deal. How many asynchronous method invokers do I have in GIPC?
You've got one.
So what's going to happen?
Well, it depends.
The second call is not going to be able to be called, invoked, till my asynchronous invoker
It's free.
is free.
So you can't. So you have the same design constraint as RMI.
Not quite. I can have two different threads execute from here. Send them in parallel. They'll reach the server, but at the server end, they'll be serialized. In fact, all calls from all sites will be serialized at the server.
So it's not an asynchronous method invoker. It's an asynchronous, meaning all method invocation happens in the second thread, but those method invocations don't happen.
So I have only one of those. I don't have multiple ones.
Priority inheritance.
Sorry?
We need priority inheritance.
Well, this is not quite that issue here. It's not quite that. Right? There's no priority. I mean, there's no priority here, right? And you're saying somehow the return value should give higher priority. You know, the ones that are sending a return value maybe should get. No, what? I mean, what priority would you assign here? What would be the priority
The
that?
later the method call, the higher the priority.
Really?
You can't.
Do you really want that in general? It so happens here in this example that works. In general, if you have two threads from the same site executing method calls, you want probably them to be occurred. Right?
Yeah, if you were, the only way you can solve the problem in general when only having one asynchronous method invoker is if you somehow manage to send along information about the entire call chain and how, like, if you could give it like a mini stack trace of all the different calls, then it can make a local decision on what the priority should be. So that's probably a bad idea.
Yeah, I mean, you could, you know, what I could have done was have a per thread queue. I could have had a per thread queue and allowed multiple asynchronous invokers there. But my feeling was that if you want things to be, yeah, so I've got a constraint like RMI, except that I'm not stopping at this end, I'm stopping at the other end.
It manifests in a different spot.
Yeah.
It gives you the same behavior, but for a different.
I do allow multiple methods. See, the thing is, it's not quite the same behavior because my procedure calls are not blocking. So I can send 500, you guys saw that performance. You know, I can have multiple procedure calls being sent. They'll get queued up here, but I don't have a block. The procedure calls get queued up there, but there's no queuing and there's no queuing here for the completion. So this is the throughput is much faster here because I added the bottleneck at that end, at the server end rather than the client end.
So when things arrive at the asynchronous method invoker, does it have its own buffer that contains method calls that it has left to execute, and then just spawns a new thread?
No. Just one thread. There's the selector thread is the producer for that. It just keeps putting calls in there, and the asynchronous invoker just keeps receiving.
So the method invoker is on its own thread. The selecting thread is over here. It adds it to its queue and then returns back down, so it's free to get more stuff. This then invokes methods, waits for them to return, invokes the next method. Okay.
Goes back to the queue.
Right.
So you guys think that I should create a separate thread for each?
Well,
That's a lot of overhead,
it is a lot of overhead.
especially for procedure calls.
Well, you could solve that by having a thread pool.
Yeah, I can have a thread pool, but again, I was wondering whether you really don't you want some kind of serialization semantics? Okay, after all, there's a shared data structure in the server, and I just figured that it should be accessed by one thread at a time. That was sort of my design.
If you had a thread pool, you'd solve our problem, but you wouldn't solve the problem in general. You could always come up with a problem big enough to make it.
If you have a thread pool, I have to have a separate, different mechanism at this end.
Yeah.
But the good news is we have factories, right? You don't like it, just change it, put another factory, and you don't have to change that much, right? So that's what I just decided to go in one way, and I said, okay, but I suppose the return value is something that could have had an ID to be just general. But I figured, why send this extra byte each time? Okay. So this is what I'm talking about here. Can I have a global received value, by the way? Could I just have had one variable rather than a queue?
If you said I'm only going to allow one function call to be
Outstanding.
thank you. Outstanding at any given time.
If only one thread was allowed.
Yeah, if you say I'm going to receive any more method calls until I'm done returning this one, then yeah, sure.
But that's not what we want, right? So so we do allow multiple threads to be executing these things, and they will get the values in. So I could have just had a global variable and said clear and return received value, right? And multiple calls can be made concurrently to a server by different threads. Okay, so this wouldn't allow that. This should be proceed. Okay. And could I have had one bounded buffer for the whole port, client port, or server port? Can I just have one queue, or do you need multiple queues?
Wait, what are you saying?
So let's say I'm a client port or a server port. How many queues do I need given the constraints I have? Given that the constraints that there's only one asynchronous thread. I'm one port. I realize different ports will have different queues.
Well, yeah, but I
Okay.
can't.
Okay, think client port, think server port. In the client port, how many queues do I need?
One.
In the server port,
You need one for each client.
one for each client. Because their threads are executing in parallel.
Yeah, but each client can only have one method call outstanding to any particular server.
So that's true. But it could be serving calls, right? So return next value in global synchronized bounded buffer. We do know that calls return in the same order as they wait under my semantics. But so these, but that's at a particular CALLEE. And so can we have global thing? Concurrent calls can be made to different CALLEEs. Okay. So we really need one bounded buffer queue per destination. That's okay, per CALLEE bounded buffer. And when you're sending the call, you just look up the destination and go and wait on that in that buffer, right? And when you process the return thing, you go and look up the source of the message, go to that queue, and go and put return value in the buffer. Okay, so it's a little bit more complicated that we have multiple bounded buffers, and at the server end is where the complication arises.
It's not that bad. It's the same semantics as when we did our blocking receives, we had to have a bounded queue for each
destination. Yeah. That was supposed to match this, so that you could transparently go and take your code and add it here. But you're right, those semantics are pretty much the semantics that in any system that has received, they will have those semantics. In fact, what you've done in your receive implementation is basically, you can't wait for the slides to be posted, right?
I just want to make sure, because I'm going to start on this right after class, that I've got all these.
You know, whenever I give a talk at a conference, many times people are taking pictures. I say, I'll post you the slides. So, I'm totally off. What were we talking about?
Sorry. We're talking about how I receive implementations mirror.
Yeah. So in fact, what your receive implementations mirror what really happens in an OS. Because what you think of as an asynchronous, the asynchronous message you guys get is very similar to the asynchronous interrupt that the operating system gets when a message comes in. And that asynchronous interrupt has to be transferred into a synchronous call. Okay, so that's pretty much what and you have nicer data structure, nicer language to deal with. But that's pretty much the logic you have to do. That's what socket receives are pretty much implemented. Okay. So my RPC return value does not have an ID for all these reasons, and I'm still not sure. I should ask Jim to help me prove the correctness of this. But I think I'd rather add an ID just to be on the safe side. But for now, that's the reasoning I went through. Okay, let's go and address another issue, which is even more fundamental than the issue we are talking about. So we worried about synchronization, which is of course very important. But proxies, do we really understand what these proxies are about and what do they do? Okay. So we know that proxies go through these ports. Okay. And let's try to go and figure out first one question. There is some division of labor, right? Some work happens in the client port, some work happens in the proxy. How much work should, what should be done? How much work should the proxy do? What's the minimum work that the proxy has to do?
It has to marshal.
Should it marshal?
It doesn't have to. If it's going to send something to the client port, its call has to be in the form of something that it can pass as a parameter.
But this is an RPC client port. This is not an object client port.
So then the proxy makes a call on the port, and the port gets figured. That's the minimum.
So it has to make, the proxy is the one that has to tell the port what? What does the port need to know? Forget about marshalling, unmarshalling. What information does the port have to know? It has to know the method and the parameters. Target object. Okay? And the proxy is what the programmer uses because they find it convenient. So which method has been called, what object it is, has to be conveyed to the port. Okay? And that's the minimum information. And do you want the proxy to do the minimum amount of work?
I'd say no.
No?
What else?
Well, because if you've got the proxy,
It could marshal. It could do the marshalling.
if you've got the proxy sitting in another thread, then it leaves your
No.
client, like the.
Same thread is going to call the client port also.
Well, yeah, I know, but I feel like if you have the server proxy doing the marshalling, it leaves the client port open to do the more fundamental stuff to communication, like serializing, deserializing.
That's what the object port does. So what's the RPC port sitting there doing? I mean, we could have more work in the RPC port, or we could have more work in the proxy. So, what should we,
Doesn't the RPC port just call the methods of the object port?
Yeah. So it also marshals.
But what if you want to change how your method is called?
What if you want to change the marshaller or something? The proxy could do it. So we don't know how the proxy is generated. Proxy is generated how? the class has to be generated. Do we really want that generation? Do we really want a dynamically generated class to do too much work?
No, probably not.
Probably not. Especially if it is generated at compile time. We'll see ways to do this generation. So a proxy, fundamentally, what is proxy? Proxy is a forwarder, right? If you think about it. So we're going to make the proxy just forward. All it's going to do is convert a transparent call to an aware call. Transparent call means that the programmer is transparent to the fact that this is remote. So the programmer just goes and says method on a proxy, just like a regular thing. And that proxy is going to take that invocation and convert that into something that's aware, that goes and says, I'm a remote call, and this is the destination object, and this is our parameters and so forth, and on this port. Okay, so that's very aware that you're making a remote call. Okay, so it is the bridge between local syntax and remote semantics, if you will. Okay, so separation of concerns, and these dashed lines that I had here were dashed because the proxy doesn't call Marshall directly. What it does, what the minimum state it has is the object ID and the port to which it has to forward. Right? Because that's a proxy object. There can be many proxy objects in a client or a server end talking to different kinds of ports. So it has to know which port to forward the call to, and it has to have some information about which object we are talking about. It could be a name or whatever. Okay? So from that, it has to go, and then based on that, it can go in call a method. So stub object keeps forwarding information, remote server and remote object. Okay? So port is the remote server and object ID is the remote object. So do only forwarding. Okay. So what is the interface between proxy and data, and not data port, I should say, and the port? Okay, this is going to be an RPC port. Assuming ready. And that, so we saw even before this, before the current subject, that there was an RPC registry that each port implemented. Okay, so you could go and register methods on that. We saw it as a simple hash table. You could say, here's my name, here's my object. Okay, so if you're a server port, you had an RPC registry connected to your port, and you could register calls, methods, objects there. Now we're going to have also another class, another interface called naming RPC. That's your aware calls. And whoever's going to go and make method invocations has to worry about naming. We'll use naming RPC. It will be the interface. And that interface is right here. We talked about, we've already seen what it is. A remote end, class, method, object args. Okay, so you can make these calls directly. You don't have to use proxies. If you are willing to go and make distribution aware calls, you just take the RPC port, give it the remote end, give it an object name, give it a method, and give it the args, and it'll happen. Okay, and here I'm automatically mapping. We've seen that we can automatically derive object names from objects and classes. Okay, so that's all I'm doing here. That if you just give an interface name, it will go and use the interface name as the object name, and if you give just the object, it will use the class name as the object name. Okay. So transparency in application means awareness in system, and this is where we see very concretely that a transparent call to a proxy gets converted into an aware call to a system object, which is my RPC. Okay. Again, to make this clear, that we have proxy, we have the object communication, and in here is the RPC port, which is really providing the awareness, aware call. Okay, so what does the proxy class look like? Okay, this is not what the proxy class in GIPC or RMI is, but let's look at the logic. Okay, we'll see how to do it better later. So it's got, this is the kind of logic. This is not real code, so who knows whether this is even half correct or not. But if I've got a counter interface, I've got a counter stub or proxy that implements that interface, right? It doesn't really do the counting. It forwards calls. Somewhere here it knows which port it's about. Okay. So somehow when the proxy is created, the proxy has to be created relative to a port. It knows what the destination is of the remote object. Okay. So it has to have information about, if you're a server, you have to know which client you're invoking the proxy on, for instance. So the port is not enough. And those get initialized, say, by the init method. And my getValue method goes and says, okay, I know I'm a counter proxy, so I'll just go and get the method for getValue. And here I know my args. My args are basically nothing because I'm getValue. My args are nothing. Okay, so I'll send my args. I've got the method, and I'll send it to the class. Okay, does that make sense? And I'll go and say whatever my value was. Okay, so I'm being called with value. I will put that value in my args, and I'll send the args across.
Where is destination as the start, right?
Sorry?
Destination is the remote objects.
Yeah, so we have to know, if I'm the server, I have to know which port am I talking about and which client at that port. Right? Because we're talking of input ports. If I'm the client, I mean, destination doesn't matter. It means just one destination. If I'm a session port, again, you're not too happy?
This doesn't throw remote exception ever.
Well, catch exception, right? So we can have remote exception, whatever, yeah. Oh, it doesn't throw.
It can't throw.
It can't throw. Oh, that's why. Oh, good. Half correct, I told you.
Does destination also need to?
Actually, I should say here throw remote exception.
Does destination also need to include information about which particular object?
No, the object has got a name. The object has got a name, and did I not put the object? Oh, I didn't have an object name there. Okay,
Right.
The object name should also be there.
Okay.
Okay, so good. Like I said, okay, so good. These things I have to change. Okay, and yeah, so I should really have had RPC port destination comma object name. Okay, but I create a counter stub. I go and give the information for the destination, and I say counter get value increment, and I'm catching exception, even though that exception will never be thrown. Okay. Okay. So let's go and talk about, this was not the real proxy. So what should the real proxy look like, and how is it really created? Okay. So the server object is created by the programmer. The proxy object is given to you guys never created a proxy directly. I mean, you use some routines, but ultimately, you didn't do that kind of stuff that I was talking about. You never named a proxy class. You never did an init. Somehow you got a proxy. Okay. So we have to figure out now how the programmer really gets a proxy. What is the interface to get a proxy? That's not we're not doing it. We're not directly instantiating the proxy class. That we know. Okay. And proxies may be created from the name of a server object that the programmer knows. Okay. And how else can a proxy be created? From? Yeah, but interface and name, right? The proxy needs the class and the object, okay? So you can go in RMI, think RMI for a minute. You can fetch a proxy from the RMI server, or you can do what? How else can you get a proxy?
You can create one with the.
In RMI? In Java RMI?
Yeah, the unicast remote object.
There you're creating a remote object. And if you're the client, you can go and look up that registered object. How else can somebody get a proxy? And this is...
I mean, the client can get it?
Oh, it's just some caller. Yeah. How can the client get
The
it?
client has to be aware of what the server object looks like, and it should have a class definition for it, or...
Yeah, so the client object can do a lookup. Right? The client object can go in RMI, okay? Which you guys understand a little better than GIPC. The server object gets created through unicast, remote object, and so forth. You export the object, and then you go and say register with the RMI server registry. The client goes and does a lookup and gets a proxy. That's how you get a handle to the proxy. How else can you get a handle to the proxy without doing a lookup? It's a very simple question, you guys. call a remote method and get back a remote, or call a remote method and send a parameter to a remote object there, to an exported object. Ultimately everything is stored in memory, right? But it's not an explicit lookup. Okay, and we'll see that creates much more problem in GIPC because of the semantics it has. So you can either do an explicit lookup or it can be created for you, maybe obtained in arguments to method calls, right? In either case, like someone said, we somehow need interface a remote object at the client. Okay, we need that interface to be around to assign to that, to declare variables of that type. Okay. So how can we go and that picture showed you the interface. So how can you generate a proxy class? We need a proxy class that has the kind that I just whizzed by. That proxy class can be compiled. Okay, and I talked about that earlier, that I can go and create a version here, and you see here a distributed inheriting RMI counter stub class, and see how big my RMI counter class is and how big my proxy class is. So the proxy can do a lot of work, especially compared to a counter. Right? So I can generate it we saw this before, so I'm just sort of recapping things to go further. Okay. So you can imagine that code I showed you, some pre-compiler goes and generates that code that is then used as a proxy class. And it has all kinds of issues. Having used this, you use RMIC to create that, and then Eclipse will go and delete that class because it didn't generate it and it doesn't know what it's doing. When you do a clean, it just gets rid of the class. You do an RMIC again and so forth. And in any case, if your class changes, you don't do an RMIC, you get out of sync. So this is not a good solution. Okay, so what we see here, is that unicast remote object has this export object. An export object somehow is involved in generating a proxy at runtime. Okay, this export object is something very alien to me because I was used to using RMIC. Okay, so in fact, one of my PhD students told me what export object. And so you've got unicast remote object, you've got some inheriting counter. You go and create a proxy from this particular object. Okay, if you're going to create a proxy from this particular object, that proxy must have a class, right? So that class is generated when the object is first exported. If you export an object of the same class multiple times, you'll use the same proxy class. Okay, so somehow this proxy class got generated at runtime, and in Java you can do that. You can go and take a string and compile it at runtime and load it at runtime. Okay, so do it both ways, and generation generates the class, runtime a proxy class and object is created. This is efficient. There's no compile runtime delay and no inconsistency as code evolves. Okay, I'm just recapping stuff we have done before. Now we're getting to the. So at runtime, a proxy class and object is created. Okay, we know that. RMI system must generate application-specific proxy classes. Every proxy class, proxy classes for different interfaces are different, right? So it's not as if there's one proxy class. There's a different proxy class for each kind of remote class. Okay, so this must mean that the RMI system has to generate this code. Okay, either Java RMI did it or GIPC did it. And possible to do it? We can just use reflection and dynamic loading, right? I can look at a class, I can look at all its methods. From the method headers, I can go and generate this code. This is very mechanical code. There's no application specific. Even though the class is application specific, the nature of the class is not application specific. Given an object, I can do this. And my question to you is, is this the way to do it? Can we have a better abstraction to generate a proxy than just use reflection?
You could have just a single proxy class that has a set of methods. You give it a class, method, arguments, and it generates a method call for that. So you would say, I'm going to take my proxy. Basically, it becomes a marshaller.
Okay, so just remember, my universal proxy class must have an interface.
Right.
my universal proxy class must have an interface that the programmer expects from the remote object.
So we have to make this as transparent to the programmer as...
That's the whole goal. Otherwise, we can just use my RPC ports. I mean, the point is, this is a mechanical part. Can't we abstract it out somehow? And that's a question I asked myself. And I said, I don't want to do this. This is abstractable.
How could you possibly abstract, like, if you don't have a class? How can you ever...
No, we are going to generate classes at runtime. Okay? But we are not going to do... We don't want to repeat the work for every class for which we generate a proxy. Somehow we want to go and have one generator that is provided by Java that will just take my class and do the right thing with it and do the forwarding. Now, where it gets forwarded to depends on the destination. So I just can't have this one generator that forwards to an arbitrary object. Somehow that generator has to be parameterized to go and forward to the right destination. So how could we parameterize this? I think when I asked myself, this has to be done possible. I kind of designed it. I said, I'm sure Java has it, and I found Java had it. And when I looked at it, I said, this is brilliant. So we're going to have some generator of a class that will generate proxies, and what the proxies do will be decided by us. Let's look at for a pattern here. So high-level abstraction. So what am I doing here? I am, we are translating my call into a method object, right? We're doing that no matter what the application class, we're generating a method object, right? So that seems to be generated, okay? Whether I like it or not, I'm doing the sprint track trace. So this is also application independent. What is the application dependent part? Right? So can we go and pass to the generator something that it can just call, and we go and just go and change where it goes? That's, again, I'm rephrasing the question. Can we just somehow abstract out the forwarding of the method? Can we give it something that understands reflection? And whatever method it has come up with, whatever arguments it come up with, it goes and passes them to one of our objects that is sent when the proxy generation is created. When we generate a proxy, we go and pass it an object and say, all your method calls should be sent to this object. And in that object, we will forward it. Okay, so we're running out of time, and I don't want to build the suspense again next time. So this is application specific, that is generatable pattern. So we want to dispatch to an application specific object, which just implements some well-known interface. And the generator will go and just invoke calls on that. Okay? So we're going to have this invocation handler, which is my destination. It's going to take the proxy as an argument, the method, and the args. Okay, we need the method and args, and it's going to take, and we can then forward from the proxy. Okay, we go and see how it's used. I'm not 100% sure about this particular how it's used. So we are going to go and say get proxy class from a bunch of interfaces. Okay, So it'll take the union of all the methods in the interfaces and generate proxy methods for that. Okay? That's easy. Then we're going to do a new proxy, and we can also we can instantiate the class, or we can just say new proxy instance, and it'll do the get proxy class, and also go and send it an invocation handler, okay, which is the handler that's going to get these calls, okay, and the invocation handler is this particular one, and why class loader? So this proxy class is not going to have a name. Okay? Its name is going to be derived from the interfaces. Think of it as a concatenation of the interfaces. So whenever I do a new proxy instance, I'm saying, please instantiate this class. Okay? And this class loader is the one that is keeping track of this mapping between, because it's not a real class name. So it goes, a class loader is the one that does new instance and so forth. So the class loader is the one that will translate that to the appropriate class. Okay? And this is the object we are passing, the method and args, and we go and look at this in the next slide. Okay, so we go and say new proxy instance counter.class get class loader. We got to send a class loader. New class counter.class. We have to go and send a list of classes. So I give the array of classes, and here's the invocation handler. Okay. Now let's just stop at this point, and I'll build this context again, and we'll see how the proxy is generated. I have the serialization slide deck. I tried YouTubing it, serializing it in some sense from the zip file, but 4 times, and it crashed on me. So for each time I tried, I've broken up into a separate part. So my serialization slide deck, I've broken into 4 files, and I just managed to get all 4 YouTubed. So they will be on YouTube. I have to also do this from other class. My computer is not going to be just having enough cycles to do it all. So I also did GIPC extensibility. I did one of those things. So I posted those. The other ones, since you guys will be spending all your time studying for your exam and not really using your desktop, while you look at the serialization YouTube, you guys maybe can volunteer to go and generate the file yourself. You just need cycles. And I'll go and post how you do it. So you guys can take the PowerPoint and generate the media file yourself. Yeah, it takes like a whole night, if you're lucky. Okay, otherwise it comes back and says, sorry, could not write the file. So, but it's crowdsourcing. I mean, such a big crowd, right? But I mean, come on, we don't have so many slides either. So if I don't get to it, you guys can always do it, and it'll probably help you in your study. Okay? Yeah, absolutely, absolutely. And if I just forget, maybe one of you can just take charge and say, okay, I'm doing this, and I'm so forth. It's just you basically do save and send. I'll post that, okay? But I just might forget. You do save and send from file, and then you say create media file, and there are 3 levels of compression, and you use the middle one, okay? Which I've tried, hit and try. If you try the maximum one, it'll never come back. Okay, we know quite a bit, whether we wanted to or not, through your assignment also about RPC. And I was looking at we were looking at proxies last time, and I wanted to tell you this general proxy pattern that exists in Java. And proxies are, proxies. Where else might you use proxies in general in computer science and distributed computing?
An object with an expensive creation cost.
So what would you do? How would the proxy will bring in another level of indirection?
Yeah, I mean, basically, the proxy just fills in something that you can pass around, and then, when an actual call is made that needs the expensive resource, then it'll create it.
Okay, so create only on demands?
Yeah.
And other things in distributed computing? Versioning? So how versioning? It'll just... Oh, yes. Have you ever seen this being done?
Yeah.
Oh, yeah, good. Good. You know, this is what grad school is about, thinking of wild ideas. And that's a good idea. I was wondering if anybody else has done that. That's cool. What do people do with proxies? To make it faster. Yeah, on demand, but web proxies? Maybe not versioning, but going to the right location, a close by location, or caching values. Okay, so proxy is a very general pattern. It's a nice pattern. So it's nice to know how you could generate proxies yourself without writing a whole pre-compiler and understanding Java syntax. So we saw this this proxy class in Java, which is a beautiful class, and so what you do is you generate proxies for some other type, right? And in fact, this is very general. It lets you generate one proxy that implements multiple interfaces. Okay? So for each method in that interface, there will be a stub method in the proxy, right? And what does that stub method really do? If you're going to be a very generic pattern, you don't want it to do anything. All you want to do, all you want to do is forward it to somebody else that does the work. Okay? And so what do? You say, look, when I'm called as a method, I will go and forward a call to an invocation handler, telling it what method was called, what arguments were passed to the method, and I'll send myself also as a reference. I don't use that in my implementation, but it's just saying, okay, you know, invocation handler, you can have me as a reference also. Okay, so if you have one invocation handler that's handling that is handling multiple instances of this proxy class, it can just decide in the proxy which way to go. Okay, so this is beautiful that you convert this whole thing through reflection. Through reflection, you generate proxy. Okay, that's what the proxy class is doing. Proxy class is this get proxy class is basically using reflection of the methods to generate the code, and that code then goes and uses reflection to tell the one who is going to forwardee, its base class, that hey, this method was called, and now you can do different things based on the method. Okay, so you can have by proxy. By having a proxy, you have a transparent code, right? You can just substitute the original object with the other object. But now you have to write aware code that sort of goes and looks at the exact method and dispatches it. So at least dispatching code you have to write. Okay? And that's better than writing a whole compiler for it. Okay? So that's the goal. And you guys remember why we have, what does get proxy class do and what does new proxy instance do? Or what could it do? Just use your brains. So get proxy class, as its name, will return a class, and get proxy new proxy instance will return an instance. What is the relationship between the two? So you have to call get proxy class before this. As it turns out, no. So why did you think it has to be called? Because you generate the class, right? So if you're not going to call this separately, then what could you do? Kind of what Rob hinted before earlier in class.
Get proxy class in
the first time. Okay. So somehow you have to go and map these interfaces to a class, because given I don't know what it must be doing. Yeah, given a set of list of interfaces, a unique proxy class, right? Because that's what the parameters are doing. So you have to go and generate some internal name, if you will, and use that name for the class, and then that name will be that instantiated. Okay, so that is why you have a class loader out. Okay, class loader is the one that you're not going to give it a regular name, and maybe you don't even give it a name. Okay? And you just have this class loader map the interfaces to the class object. Okay, so that's why you need a class object. Okay, why class loader? It stores unnamed class objects for this and our later references. Okay. So that's the basic idea, and now this invocation handler can do caching, redirection, translation from one version to the other. I mean, you can do all kinds of fun things. I mean, when I saw this, I said, well, I'm going to use this a lot now. So here's a simple usage. I say class loader. How did we get a class loader in the first place? Okay, every class has a class loader with it. And so you can just say, whoever my class loader was, I'm just passing it that class loader. Okay. I'm sending it an array of counter of interfaces. It's just one. And I'm sending it some invocation handler. Who knows what it's doing, but at least this shows you the syntax. Okay. And the invocation handler is the one that you instantiate. So it can have state that you need to go and implement the proxy semantics. And I showed you earlier some proxy code which is all wrong because it was not real code. But now this is real code. It may still be all wrong. And you see what's happening. My invocation handler, the state that I was putting into the proxy, which I didn't put all the correct state into the proxy that I showed you earlier because it was not a real proxy. This is the state that I should have put into it, which I'm putting into the invocation handler now. My proxies are stateless, except for the invocation handler, right? And I'm saying, okay, this is the port to which you should forward things. This is the destination. Okay, if I'm a server port, it matters. This is the remote type, which is just used, because for my call. And this is my name. And my name is sort of the ID of the remote object. The name needn't have been given to me, in which case I generate the name from my type. Okay. So if I say name is not equal to null, I'll call destination name method args. Okay. And this will just go and make a call on the RPC port. Okay. This will call an abstract method in this class. Okay. And otherwise, I go and use the remote type. Okay. If the remote type is not null, I use the remote type. Otherwise, I just use the destination name. So I'm using some defaults for going forward. Okay. But you see now a real invocation handler, which is the abstract thing. I subclass it in many different ways. And this is one of the subclasses. My subclass is just taking the call method and sending it to the RPC input port. Okay, so this is where the abstract method has been implemented. Okay, so you get to see now how control transfers from a proxy to the RPC port. Okay, questions? And here's my generate proxy thing. The static RPC proxy generator is used for many other objects. This is just the canonical one. Proxies are generated only if they're necessary. And so this is sort of the one that generates, and it says, let me go and take the class that has been passed to me. And what is this get proxy interfaces doing, you think?
Getting an array of classes.
Of implemented by which class?
The one that has that.
This class? As it turns out, I also look at the superclass.
Oh yeah, the whole thing.
The whole thing. I think reflection doesn't give me the interfaces directly. So I saw in my code that I seem to be going to the superclass also and getting its interfaces. Okay? And I pass those interfaces to this thing, and I go and get this invocation handler. From that, I get the port, destination, class, object name. So my generate RPC proxy must give me all this data, and I go and generate the proxy instance. Okay? So this is how it's done. Okay. So proxy method generated for all interfaces by the class and the superclasses, including objects. Including object equals and so forth, right? And in RMI, only the remote interfaces are used. If you have more than one remote interface, are they both used when you export an object? Do you guys remember? Or does it look for the first one? And I suppose I think it should logically use all the remote interfaces. But the basic idea of proxy generation is the same. That's just a little detail. In fact, I saw my note from last time. My last time the call was get remote interface. Oh, in fact, look at this. I used to get the remote interfaces only, and I just changed my mind at some point. Okay. But this code is not to be used. Okay, now let's go to some architectural issues. Okay, so we know what a proxy looks like and how in RMI or in GIPC we can generate proxies. Okay, And this proxy class is the one that we use. Let's just go and figure out exactly what control flow happens to invoke, to create a proxy. How a proxy is really created. I mean, if the call is made, it will be created. But what triggers the call? And in RMI registry, we start with a remote object. And when is a proxy created for this remote object? What triggers a proxy creation? No. You guys are thinking too much GIPC nowadays. Before you register, sorry? There's lookup, there's create, and there's another very important operation that is the proxy operation. Bind is register. Bind is register, then there's lookup, right? So whatever I forget the names, but there's one that says register, one that says lookup. What are you registering when you register? Remote object or? You see, you guys have got confused between, it's like I learned French and English French and German without really understanding them, so I keep confusing between them. You guys are confusing between GIPC and RMI, and by Tuesday, you better have understood these languages properly, right? So what really, you give the remote object as an argument, right? That's true. Asit said was right, that you create a remote object, you bind it. But what is bind really doing? Yeah, RMI. Forget GIPC for now.
Binding the objects of the proxy.
What's another very important operation that in RMI?
Export object.
Export object. What does export object do?
Creates a stub and then we export that stub.
So somewhere export object goes to some table and says, for this remote object, this is the stub. And when you go and say export bind, it goes and says, do I have a stub for this? If so, let me go and send it.
So bind, when you call bind, you actually have to call it stub. You bind the stub, not the object.
No, you bind the object.
Unicast or-
You never get a reference to the proxy directly. You create a remote object that could be a subclass or a unicast remote object, or it could not. Okay?
And it assuming that it's not in general.
Then you go and export the object.
And I do a unicast remote object or export object, and I get a return
No.
value.
No, there's no return value for that.
I think there is a
There is
Oh, but you don't register that. If there is, you don't register that.
I've always registered the stuff. I'm very careful to get the return
No,
value.
I didn't even know there was a return value. You just register the remote object.
I always register the
Anybody else? Have you guys all registered the?
What he's saying sounds extremely familiar.
Yeah. I get the stuff. I always do object or whatever stuff equals unicast remote object or export object, and then you export, and then when you do naming or rebind, you always
So export object must be an overloaded method. Bind must be an overloaded method. It must have one that takes remote as an interface, and another one that takes a proxy as an interface. Okay, I've never done
This is how I did it in the assignment.
Okay, but you don't have to. I didn't even know you got back a proxy. I didn't even know you had to get a value back. Okay, so export by its name seems to indicate it's like a procedure. You're not saying get object. You're saying export it. Just create some state. And so it creates that thing. And when all the examples that I showed you guys, which do run, just like my tracer runs, didn't do that. Okay. So what happens? You export object. At that point, a proxy is created. Okay, and it's also returned, as you guys say. And then when you do rebind on the remote object, or you can do it on the proxy also, I guess, that sends a proxy to the RMI registry, right? And now you do a lookup, and it goes in, gets that.
So how did you do it without rebinding?
No, I rebind, but I rebind the original object.
So what's the purpose of export object then?
It just creates a proxy. It's the side effect. I think of that as a side effect method.
Okay. So you don't use its return value for anything.
No,
do you?
I didn't even know it had return value.
Yeah, it returns the stub.
Yeah, I didn't know that. Okay, I just, and a lot of times my program won't work, and I just add the export object and change nothing else on the program, and it works.
her guy, and I'm just going to follow me.
You're saying you don't need to export?
I think you're thinking sync.
You are thinking sync. Yeah, maybe that.
Too many foreign languages here. Okay, so okay, that's how proxies are created there. And by the way, those of you who are looking at the internet, just look at export object. What kind of arguments does it take?
It takes in a remote object and it returns to you either something remote.
No. Sorry. Look up what bind does. What rebind does.
Rebind actually doesn't return.
No. What does it take as an argument?
Isn't it overloaded?
String, name, and remote.
Remote. So proxy must also be remote then.
It does. Stub also implements remote.
So
When the return value of export object returns either remote or remote stub, one of those two.
why one or the other?
Based on the arguments could either provide you or it's just.
Why would it not be a proxy? Okay. But you can see that I can pass to rebind a remote that has not been, that is not a proxy. My original object is also remote, so it takes that as an argument. It must be doing some checkup.
So if you only pass it the remote object, it returns to you a remote stub. But if you pass it an object and a port, then it returns remote. Otherwise, it returns stub. If you pass it an object, a port, and a socket factory and a server socket factory, then it also returns you a remote. Otherwise, it returns stub. If you just pass it, if you just do export object with object without the port argument.
Yeah, it still doesn't make sense to me. But this is what I was telling you guys, that even in RMI, you can pass it a socket. That is a socket factory. You just send it to socket object, and it'll use your socket in that case. Okay? Okay. In GIPC, what's the difference now? How do you get a proxy? We sort of saw that. We saw that call. And we saw there was a static RPC generator, which was sort of the base class. And now I've got some indirection here. And I go and actually say generate RPC proxy, okay? And that's just like your export object, okay? But this I can do, this doesn't take a remote object as an argument, this takes the type, class, and name, okay? So this doesn't, unlike RMI, it doesn't require a remote object. So it's not as if you get a proxy from the server, you can generate a proxy locally. We saw that, you guys know that, right? So I can in fact generate the proxy before I even have the remote object, and this late binding we saw was going to be useful, and we see that again today. Okay, so you go and make a call like this. You get a proxy, and the remote object may or may not exist at this point, and that's my directed server proxy. And I've got two adjectives: direct and server before proxy. So what other adjectives could exist here? So I could generate a proxy because the client and server definition is relative to the port, right? One port was the one that was registered, the other port is the one that's. But whenever I get a proxy, you always think that the client always gets a proxy. No, the server can also get a proxy because it's going to call into the client. Okay, so we can have a client proxy, and what would indirect really mean? Seems like a binding time issue. And remember, the advantage of having a proxy without the remote object is flexible binding. So you don't bind to a port you need. Because where else are you going to direct it? What are you going to use if it's not? So port you need, class you need. Okay. Name, could this be dynamically bound? Dynamically set?
Sure, but you still have to give it the instantiation of the proxy.
Maybe the proxy uses some global state in the port to determine where it should direct the call to, or the invocation handler. So you just, and what would be, what could be some distinguished name or names that could be dynamically determined.
The name, the server, and the client.
So that's fine. They're fixed, right? Server's got a name. So now you're making a proxy. So you've got some port.
Right, so the port.
And now you've got connections. You've got multiple clients connected to one server. Okay. Now at the client end, is there really any mystery as to where the call should go?
No, so it's going to go to the server.
It's with the server now. It could go to, if I don't give a client name, what are my choices?
Just a number. Like every client that connects, the first one gets 1, the second one gets
So, but which one do I choose then?
What?
If I don't specify to the proxy which client it is, it should choose some logical
Yeah, if I
name
do
or
that,
names.
say,
I'm giving you lots of hint here.
what?
It has to pick the destination among some subset of the destination it has to pick. It's got all these clients connecting to it. We went through this. Derek was the one who answered that question last time. So I'm going to look. You said give it numbers, but then that seems to me that I should use a random number generator to pick one of those numbers, right? That doesn't make sense. You could, and that's called any cast. I could just go and use a random number generator.
We can send it to all of them.
Okay, all of them. And what's another very good one to send to? Previous, the last guy. And what's the complement of that?
Everyone but the previous?
Which is sent to others. Which you guys do all the time when you relay messages. Right? So, those are my choices. What's happening here? Okay. So, at the client end, I have to see at the server end, at the server end, I have to give a remote end to say this is the one I want to make a call to, if it's directed. If I'm at the client, I don't have to go and give the name of the destination because that is the server. Okay, I have to give the name of the object, but not the destination. At the server end, I have to give this extra argument. So that just shows you the client versus server proxy. They're both directed. This guy's going to the server, and this server is going to this particular client. Right? And now, in reply proxy, so this is the proxy you get here. Okay, and you've got the remote end as an extra argument that has to be given to it. And after that point, the remote object could actually be registered. So you can generate the reply proxy before the client even exists, which is what you would do at the server end, right? Now we've got, and this just shows you an example in RMI that you can't. And now here's my reply proxy generator. This is a different kind of proxy with a different invocation handler that says I don't need a remote end because I will use. This is a reply proxy, different kind of proxy. I will use. My input port has get connections and get remote endpoint, and in the case of directed, I always send it to the remote endpoint. In the case of reply, I send it to the last caller. Okay, which we saw. You've seen the reply thing there. Then I just go and query the port to say who the last caller is and send the call. Okay, and this is not such an interesting one, but it's a good thing because it's a complement of the one we really want, group proxy. So if you don't have a group port in RMI, you've got to maintain your own list, right? That's something that GIPC could do for you. And so you have to sort of have a connect call essentially that connects all the clients together into a session. And you have to implement that. In GIPC, you just the connections you have are kept and used for multicast. So you don't have to, so you just have an others and all proxy. So you can say generate others proxy or generate all proxy. Others will look at the complement of the last call. All will go and send it to everybody. Okay. Right?
This is just where the return of any remote function call goes, right?
This is where the function call goes. So you sent a message to the server saying relay. The relay goes and makes another call back to all the clients saying, send to all the message I just got. That's what you guys do, right, in your server. So this is a call being made by the server on the clients. This is the callback. And the question is, should it go back, when the server is communicating with the clients, should it communicate with a specific client, known at proxy generation time, to the replier, or to others, or to all? And at the server end, you will go and generate this proxy. So the client is not going to be registering their object for callback. The clients are all going to be exporting remote objects. Or basically, you know, they're going to just have remote objects that they've registered. Okay, you seem to still dissatisfied.
Like, why would the client shouldn't be like registering their remote objects? The server should be the one registering the remote objects, and clients should be passing remote references of themselves.
Why? Just because RMI brainwashed you into that, that's why it should happen?
It's just you want to minimize the amount of stuff that's lookupable. You know, like only like it's like it violates the client server paradigm. Like the server is the only thing that's globally you can look up the server, and the clients can then send information about themselves. To
Okay,
the
so
server.
let's go and see this. This is a very important principle, least privilege.
What?
The least privilege principle, right? You guys, least privilege?
You
What's-
get the least privileges you need to do your job.
That's why you don't make methods public. I mean, don't make variables public. Okay.
Because clients shouldn't be.
So when the client registered itself in GIPC as a remote object, what is it really trying to do? So it's saying that, look, I'm callable, right? I'm callable by the server.
By the server, but then it should only be callable.
It is only callable by the server.
Why? Others might be able to look up.
No, they can't. This is not RMI. You can only the server can call back. The client cannot call back into another client.
Yeah. So like I'm getting it now. So like these proxies are your way of getting to the other clients if you need to. You have to go through the server to get to them.
In RMI, I would have to first create a proxy, send it to the server, then it goes and calls back. Here, I can just register it. You know, the client can just register it.
Register it with a name, with a specific address up there.
Right.
What's stopping another client from accessing?
You can't. You just can't. It's not. The implementation doesn't allow it.
Yeah, there just isn't a method that it can call on the server that says, "Give me this client."
There is no direct connection between the clients. In session port, there is. There is no physical way for a client to go and call a method in another client. Okay, and this is actually more safe than RMI. In RMI, when you go and send your object to the server, you have to export the object before you send it to the server. When you export an object, you're essentially going and creating a connection at your end, which all the other clients can connect. And that's actually more flexible because you can send proxy from one client to the server, which can send it to the client, and it's very nice that way. But it gives more privileges. Okay, so this is actually. So the drawback of GIPC is that proxies are not transferable. In this kind of port, in session port, they are transferable.
Right.
Okay. Okay, now let's go and solve this call. I mean, this group remote procedure call, nobody else in the world has ever even been crazy enough to support. In procedure calls, it's okay. I go and make the same procedure call in multiple places. What if the function returns a value? I mean, if you're relaying, it doesn't return a value. So, stupid question, right? But in general,
But if you make a call to multiple clients,
what should be the return value of that?
returns a value. I mean, you could be the first that comes back. You could have an aggregate function that adds them all together.
Yeah, just return an array list.
What else study in parallel?
Return them all. Return a random one.
Return them all, like have a special object that like wraps the return value, has some information like where it came from, like which client.
No, you don't want. If you want all that information, you use aware calls. Then you use aware calls. You go and send. I'm sending to the. I mean, you can always go and, call, say which connection, which is the current caller, who's the current caller. But all values will be come back as a return value of the function. adding anything more. We're not adding some special type. I guess you could, but that just makes you much more aware of the other ends. And when you make a call to a server, the server doesn't know who called it in a transparent call. Okay. So you can return
You can just return a list of all of it.
you can return an array of things. Okay. So of course, I mean, we guys can write our own proxies to do all this stuff, but by default, that is what GIPC does. But if I'm returning an array and the return value is integer, how do I give it an array of integers? That's what the type of proxy is. It was integer. So we have some problems, and we have to put some constraints, and we have to either say, look, function calls cannot be made at all. You can't multicast function calls. I can just have a rule. That'll get me, let me a lot of benefit. Or I can say, if you have a function call, the type of the return value should be
An array.
But then I have to return an array of arrays. Because I have to be able to, the same function I might call directly or in a proxy, So we'll just make it, we'll just make it object. Why?
That's not very transparent.
So I'm just saying you can't, by definition. This is an interesting thing that you just can't make it completely transparent. Unless I go and choose the first one.
Or some arbitrary choice.
Yeah, non-determinism. Yeah, that's possible. And that would require probably just changing one line of code. Okay. So you just go and say object, you just go and cast it as an array. Okay. An exception if return value is not an object, actually. Okay, so you'll get a class cast exception. Or maybe even a generation, yeah. Text. And what does this get you? You don't have to go and maintain your own list, make group calls. And this is something we went through earlier, but it's good revision for the exam. I haven't written the exam, so I don't know if it's good or not, but it's revision for the exam. So what are my choices? I want to do a group called remote procedure call. And I can multicast and marshal, or marshal and multicast. We saw this point before. Okay? Same thing with serialization, same thing with marshalling also. And we went through this before. And what this really lets me do, and I think I've got this working, or I've got this almost working, is that, can you see how that marshal and multicast is going to be useful in this scenario with group calls?
You can marshal at the layer client and then multicast at the server.
And then unmarshal at the other client.
Yeah.
And I have group session ports where the session server and relay are built into the first port itself. And I can just, I don't know 100% if it works or not, but I know I had that a design goal, that this actually will go without any serialization in here. And which is what you really want, right? So you see that how this group call, why it's, writing a loop is very easy. It's not a big deal, except you have to provide those methods. But having this performance benefit is a big deal. Otherwise, you needlessly, and you don't need any class paths here. That's the best thing. You don't need to have those objects present here. Okay. So you can do this. I'm just giving you the alternatives, and this is marshal and multicast. So let's understand parameters now. Proxies are created from names of server objects, right? So you go and do a lookup, or you get the proxy in a method call. So we've really looked at this part so far. Right? Given a name, we went and told the generator, please go and generate a proxy. Okay? So now, what do we have to do to get proxies and arguments to method calls? How does this work? We know how this works because we made a call. When you guys said new proxy or whatever, it was calling one of these generators to go and generate the proxy. But then you also were able to get a proxy in just a method call, and this is the same thing in RMI. So what's really happening then behind the scenes? In RMI, what happens? Yeah, so you can get proxies in parameters or method calls, right? How does that work? So I invoke a method in you, and the side effect of that is that you get a proxy that points to an object in my system. That's how you guys supported callbacks. By the way, in RMI, did you guys, when the client sent itself to the server, did it send a proxy to the server, or did it send itself? Asad? When you send, did you send a proxy or did you send itself? Because you had to do itself. Why not a proxy? You had to export that object.
Yeah, but the fact is that whenever I work with clients, I normally never export it because I always send it.
That's the same thing as export. That's like saying
Exactly, but I do it to a physical export object call, which means that I never actually get a handle to it.
that again proves my point that bind will take an object as an argument something that is not a proxy.
Yeah, but why does it work when because at the server end, I don't extend from Unicast remote object. So at the server end, when I export it, when I do a Unicast remote object or export object, I get back.
I understand, and I learned that from you guys.
So the naming.rebind call, are you saying that it works for both remote objects and their stuff?
I'm just telling you that there is the fact that there's a table mapping between the remote object and proxy is evident by the fact that when you make a call from a client to the server, you send the remote object directly,
Yes.
and obviously a proxy is sent there, right?
Yes.
So it must be doing some lookup,
Yeah.
even though that object better have been exported. Okay, so that is how I looked at the world, and I said it's working in this case in this way, so it must also work in rebind the same way, and it did. Okay.
And that lookup is actually done at the RMI layer.
Yes,
Yeah, RMI will see that you're sending an object over a remote method call. Be like, okay, but we've got a proxy for that. Put the proxy in there and then send it all.
And if there's not a proxy,
Then you get it.
serialize it, and we send it serialized.
Okay.
But then you get a problem because it just serializes it. And
Yeah.
since
Yeah,
it's
yeah.
proxy, Then trying to
Then
get
it's
call
not,
back
then it's
will.
not linked to the remote.
And it may not be serializable, in which case you'll get a real problem.
Yeah.
With the, okay, so that's how it works. That when you send a method, so what's happening when yeah?
Will it try to auto-generate a proxy for you if you're trying to send?
No,
a
not RMI, not RMI, but I will.
Okay.
I
But
will.
I was trying to remember whether you could send the client because the client extended
And-
remote and not have to do an export first. I can't remember how I did that.
And now I understand some of Asad's questions, which I said, why is he asking these stupid questions? He was sending the proxies in GIPC. So he was saying, I'm sending a proxy to the server, and it's barfing on me. And I said, send the remote object. Because I just figured that, you guys always deal with remote objects. You don't deal with proxies. I didn't realize that from RMI, you were trained to get proxies and send them.
Wait, so in your RMI example, you sent the stub along instead of this? Okay.
Okay.
That explains a lot.
So now I understand, because I never knew you actually got a value back from export object.
From the server.
Yeah.
Whenever I want to pass something from the server to the client, I always pass the stuff because the server didn't inherit from the last remote object, the client always did. It's just something that I.
Oh, so you didn't even have to export your.
Yeah, I didn't
client.
have to export.
No, in RMI you have to export, yeah. In GIPC, you
Even
don't
if
do
it
it.
extends Unicast.
Oh, that is exported.
Okay.
In the constructor of that, it exports. Okay, so the question first is, assuming we can send either the object or the proxy, and how the proxy is sent, we just got the idea. Which should we send? Right? And in RMI, what is the decision made? Send if it is.
If possible.
Yeah. So if it's so in RMI, only remote instances can be exported. Okay, and you must do an export of that. Okay, that's RMI. That's not GIPC. So it first checks is it exported and remote. Okay, send the proxy. Otherwise, it checks is it serializable, serialized, or okay, not serializable exception. And in GIPC, what's the algorithm? What you guys have figured out? Firstly,
It will look at it, figure out if it's remote. If it is remote, create a proxy, send the proxy along. If it's not remote, is it serializable? If so, serialize it, send it along. If not, not serializable exception. Except, you actually get that one? Is that the one that was getting caught for you guys? And you couldn't? So like we tried, for instance, in this assignment for part 2, if your remote procedure call INVOKER, where you handle like return value of remote procedure call and you try to send null back, it won't work. It'll never send it because null is not serializable.
No falls through in your catches.
Yeah, just
Hang on. I'm too tired right now to think this through. Okay, tell me again. So null.
In the return value of remote procedure call in your receive call.
Yeah, you have to send. You have to go and put. You have to put null within an RPC return value. Right?
Yes.
I mean that makes perfect sense.
But the point is, you can also you can literally send back any object that you want. It's like
Sure.
I send back a string prop.
No, why not? Because tomorrow, when you guys are doing your function calls, you should have. I hope you didn't use RPC return value. You should have used some other object to send it back, right?
What?
When you guys do your remote procedure call, what kind of act do you send back?
I send back a string.
I sent back an empty object.
Ideally, you should have gone and created a new type.
And that's what it created a new blank type.
Yeah.
That implements
So
your-
obviously, I can send back anything in response. I want that feature. That's a bug, not a bug. It's a feature. I had to work hard to go and.
The bug, if we're going to call it that, is
Yeah.
that if you try to send null through, you don't get an error. It just doesn't send.
Oh, if you send null back.
Yeah, so like-
you do instance of, and then the last else is like, it comes down to tracer message. Sorry.
Okay. So you meaning the sent call, received call invoker?
Yeah, the received call invoker will try to do reply.reply, the source, and then null. And if it tries to send the null through,
Yeah, if it tries to send null,
You don't throw a null pointer exception.
yeah, there aren't no exception gets
Yeah,
thrown.
it's-
It just falls through.
So you're saying don't send anything, right? So what should have happened?
Should have fired a null pointer exception because reply doesn't handle nulls.
So you say reply.
And put null there as the thing to.
That's what I do, right? If I do that, and I send that reply null value, or you send that?
No, you would send-
We're sending it.
If we see, like the thing is, when you have remote procedure,
So
we're
if-
expecting a return value, so we're just like, oh, well, we'll just send null back
Because it's the smallest possible
just doesn't,
thing you
yeah,
can send.
it's the smallest thing you can send, but it doesn't work because it won't actually send the null across the wire.
And it should, you think?
Yeah, I think you should throw a null pointer.
No, or should I send it?
Send it if you want. Or do an
Because
exception.
well, the thing is, null itself is not serializable.
No, is it not?
No,
No.
null is an object, so it can't implement serializable.
But you let it fall through.
But we can send null values in serializable objects, right?
Yes,
Yeah.
well, we can because
Yeah.
our serializer.
But RMI doesn't. I mean, sorry, Java doesn't allow that.
We don't know because you're doing instance of,
I've never
instance of,
tried it.
and then if it's
Probably
not-
does allow it to send, but you can't send null at the top level value.
Not in GIPC at least.
I know that the Java language itself has like some dummy classes to stand in for some things. Like I know there's a dummy class that's like java.lang.void with a capital V. So I was going to use that, but I didn't know.
So basically, what I should do is that, and who's the one? So which layer of mine just stops null from being sent?
So in the receive call invoker, we
Yeah, and somewhere it says if null, don't do anything silently.
yeah. So when you in the send call completer, we did a synchronous procedure call.
Yeah, I understand that.
So
And the receive call, you want to just send the null back. That's what you want to do, right? Yeah,
So
I
we
understand
wanted to
that.
send null because it's
Yeah,
a small.
and you get stopped at some point.
Well,
and-
no,
It
we
doesn't
don't get
stop.
stopped. We call replier.reply and send back to the client a null,
Yeah,
but it falls through your if statement. So it's
in which
in reply. So in reply it does if instance of
serializable.
serializable, do something, and then there might be another if instance.
So null is not an instance of serializable?
No,
I didn't know that
that was causing me so much grief. Yes, sorry.
because I didn't know that.
I mean, the fix was
Simple.
just send
So you
something.
you check if it's equal to null before you check instance of serializable. Because null is an instance of everything.
I guess.
Hold on, that's some scratch code. Let's find out.
No, I'm just saying, no, it's not, obviously, but conceptually to me, it's an instance of everything. You
Well,
can,
it could be.
Or nothing.
Yeah, it's just nothing.
It's like a void pointers and everything.
no, but you can assign to anything null.
Oh, okay. I see what you're saying. Yeah.
Not in the end. Not in the end.
It gets, I mean, we're talking objects. Okay. So, send me a message of this kind. And tell me what I should do. And I'll Who answered that first? What I should do?
We don't know.
We don't know. We kind of.
Yeah, no, but no, tell me how to fix it. Obviously, finding a bug is easy, but fixing it, tell me what I should really do.
For return java.lang.void if it's serialized.
No, I need to just go and check. I should just allow the null to pass through. Why not? I didn't know. I mean, I never tried sending null, so I never knew this.
So I don't even know if the Java serializer will try to serialize null, because null is not an instance of serializer.
So it probably has a special case saying if it's equal to null, send it, or if it's serializable, send it, which is what I'm going to do now. Right?
Because all of our serializers can handle null, so I can only.
Yeah,
We
and
had a dummy thing to handle it.
Yeah, I mean, we had this explicit case: if it's null, then serialize it like a null,
And my slides, I mean, what I wrote, like you guys, did the same thing, but I just didn't have this, didn't know this. Okay, GIPC, remote, get a proxy, serializable, serialized, otherwise I send a proxy.
Wait.
Yeah,
You try to generate a proxy for something that's neither remote nor serializable.
you guys saw that. You guys saw that in the very first assignment.
You assume that it's remote.
I don't need remote to generate proxies. I say, sure, we don't care about exceptions.
Oh, that's right, because you don't check for the remote exception. Okay.
Okay, so this, sorry? No, remote is orthogonal to serializable. It's just tag. So again, you can just see that if you get down to it, every decision can be made in a different way. Okay, and this is how I get to have equals and other methods also invoked remotely.
But what exception gets thrown if a remote exception should have been thrown? So like say you've got like the network disconnects or something crazy like that. What exception would you get?
You can always go and catch class. You can always catch exceptions you want to. If this particular object implements remote, then of course if you really want to catch exceptions, you'll make it implement remote. So what this is saying is that I'll send the object across. This is sort of trying to do as much, when in doubt, do, and sure you don't get the checking. And you can have an unchecked code, but remote exception will be thrown. I think, I forget.
So when the null is passed and the remote exception should be thrown, or will be?
I don't know about null. I didn't even think about null. Okay, I thought null was serializable, so null was just here. Whatever, this is my loop. If instance of is null, instance of remote, I don't know. But I might be handling null in some. I might not even be handling null properly. Who knows? Okay. But I've sent null values in parameters, and they seem to go fine.
Yeah, they get like when you're sending them along inside something else, it works fine.
Yeah. That's just because of that check that you just told me about. Right? So let's go and get this right. So how is this implemented? Okay, so we have to first make a choice, proxy or serializable, and we've seen that there's multiple ways to make the choice. Let's just go and see exactly how proxies are generated in this way. And you guys remember in RMI how this happens? How do you send a proxy exactly? I mean, what code gets executed? How do you replace an object with a proxy? I mean, you have to do it, right? But I talked about this earlier, inheritance and delegation. So there's object output stream has a replace object method, which by default just sends back the object. Whatever object it was, it sends it back. And now what can you do to do marshalling? You have an RMI marshaller that goes and overrides the replace object thing, checks if the object is, then goes through the algorithm and says, is it remote? If so, send the proxy that I have in my table. Else, send the serialized object itself. Okay, so just getting into the details, how the architecture works, and how we really see the difference between marshalling and serialization. Okay. And in GIPC, I mentioned this to you earlier, we use delegation. Okay, so we have this object that goes and transforms sent reference. That makes sense, right? That you're sending a reference across and you want to transform it. Transform received reference, does that make sense?
Translate. There was a translate. It should be translate.
Yeah.
In fact, I think probably is translate.
What's the difference, guys? I mean, I don't know. I don't know what it is, but is there really a fundamental English difference between translate and transform?
Yes.
Translate. Okay. Yeah.
Also, like,
Yeah.
transform
Okay.
sort
Thank
of
you.
implies you're doing something to the object itself, not replacing it with something else.
Yeah. Yeah.
I mean, if
But-
it's a
What? No,
translate-
I'll tell you.
semantics.
I'll tell you why I named it, because I actually get a list of arguments,
Right.
and I transform the list of arguments into another list of arguments. The same. I just take that pointer and point now to this object rather than this
Yeah,
object.
but the procedure itself is a black box to whoever is following.
So this should take. Yeah, I should.
Translator is-
Okay. Good. You know, I'm very heavy on words, and thank you. So why should I really be translating the received reference also?
Well, wouldn't you need to?
We do know that you had to override your handle procedure method because you don't want to be doing any sort of translating as you were doing in duplex and for procedure. You need to physically override that method and absolutely not.
No. So the received reference will be received in response to what?
So you've gotten some object from the remote
Guy,
thing,
right?
and now it's got some reference to an object in it that was transformed at the other end. Now you've got to do a lookup to get the original object that it's talking about.
So that's taking the possibly remote object and replacing it with the local object.
So that-
you
Oh,
okay.
Because someone sends you a proxy as an argument, and you're like, oh, I have that local object, and you need to operate on that.
So
local
you
object.
needn't do this. In RMI, it doesn't do this kind of stuff. Okay? RMI had a replace object only in output stream. It did not have a replace object in input stream. Okay? For some crazy reason, we'll go that into later. I also go and translate the incoming guys for the reasons you guys are mentioning, because I want economy of proxies. Okay? So so that's what this is saying. Okay? But okay, so yeah, transform, and there's some other helper methods which I want to get into.
I'm sorry, what's the difference between the first two transforms and the second two transforms?
One is doing it for a list, and the other is doing it for individual object.
But can't you just place a check inside and say if it's an instance of array?
But if you're
No.
transforming an array, you don't want to return anything.
No. This guy calls this. The array guy goes and takes every object in the array and calls transform receive. It's just a simple.
Right, but I'm saying like just with like object array is also an instance of object, right?
No, but I have to go through each element. This is my element and see whether it's remote or proxy, remote or serializable. I've got to do this for each element of the
Yeah, but
object.
I'm just saying that you could have like an if, and like just for the sake of collapsing everything, you wanted to have an if else check, and you could say if it's an instance of array, do this, else do that.
You don't understand. My args is the list of arguments I want to send.
Right.
It's always be an array.
Always.
Now-
It only has one element.
Yeah.
Yes, it'll be an array.
It'll be an array, and then I have to go to each element and transform it, right?
So you can call yourself. You call the upper method.
That's what I do. Yeah, that's what I do. That's why it's a very simple thing here. I'm just not doing it all in one method. I'm just going in. Okay. So this is what really happens. Our local and remote send and remote trappers have not only the synchronizing shared data structure, they also have a reference to a local translator. Okay, and somehow the state that I send has to be correlated to the state I get back. Okay, and the reason you guys said that if I sent a proxy, a remote object, and a proxy got sent, and I got the proxy back, I want to return the original original remote object, and you will see that later. Okay, which RMI doesn't do. Okay, so because I go and do this input translation, I have to go and have the shared state. Okay.
So in RMI, if it gets a proxy back, like to something that the local machine actually has the original object for, it has to loop back on its network interface to
It'll do the short circuit there. But if I send an object and get it back, and I do equals equals, they'll be different.
because it lives in the proxy instead of the object.
And I went through I don't know why that's a bad idea, but I thought that was a bad idea. So I go through this great hoops to go and give back the remote object. Yes?
It makes sense.
Makes.
If you have it locally, you might as well save yourself the call to the networking stack.
And you might as well know that I got back my object. That object might be in some hash table, and it might be using it for various reasons. So that's what I do. Yeah. So that's why I have this back. So I probably won't get to the slides that are going to talk about this in depth, but at least you get an idea why this is happening. Okay. So let me just look at the architecture right now. We have the shared state consists of two items. the sent call completer and the local remote translator. And you guys might have seen this when you were debugging through your code, and that's why I have this shit state. And my send trapper goes and does, uses a translator to go and marshal, and then goes and then goes and returns value of the remote method call. Okay. So before sending the value, it marshals. It uses one piece of shared state, and after sending the value, it goes and waits for completion. Okay. So I told you half the story before. I'm telling you the full story right now. Okay. And my return value also. So references you can receive not only in method calls, but also in return values, right? I might return back a remote object, in which case I've got to go and create a proxy for that. I might have to transmit it back. Okay. And so you're seeing that this translation is happening many places. The receive call invoker is also getting that. So you have to basically at every level where you have to deal with arguments or return values, you have to do this translation. Okay. That's what this code is saying. Yeah, what happened there?
No, too soon.
Okay, guys. Let us understand how this whole thing works. This whole elephant works now. Okay. So, I hope I didn't make it. If I made it and lost it, I'm just really heartbroken. It takes forever. Disappear, maybe appear. Oh God, it's I want my generator to generate these calls. So you make a call on a proxy method. That goes and makes a call on the port, right? Port implements many interfaces, one of which is naming RPC, which is where you have these aware calls. Okay? And that is going to go and then marshal the call, right? Get back an object, send that stuff to the send trapper. Send trapper is going to go to the translator, get back what it needs to really send, and make a call into maybe process return value, okay, which goes and makes a call to take return value. Okay, you've seen this part before. You've seen many of these parts before, and you in fact seen the other part too. I'm just telling you all the objects that are involved. Okay, and so that's my caller flow. Now when the message is received, it notifies in the receive trapper the method, which goes and then again calls transform return value, gets back any transformation of it, puts that return value here, and then goes and that will go and unblock this guy.
Where's the method call actually executed in this?
So this is the caller.
Oh, okay.
My magic, this happened. Okay. And message received, notify port message. What? It's not even aligned. I don't know what happened here. Notify port received, message received. You put it in a blocking queue, which is going to be serviced by who? Which is this runnable here? No. This is the selected thread here.
There's a thread running.
That's the asynchronous thread invoker.
Okay.
That takes the value, goes and calls message received here, and that goes and then transform the received reference, calls the method, gets a return value, now goes and transforms. Okay, so the first one was transforming received reference. Now it goes and transforms the return value and sends it to the send trapper.
What's that line on the far right?
A line that shouldn't have existed.
Okay.
If I get the right version a little later, I'll be happy. But anyway, so you guys get to see this whole, and I might not get a chance to animate this, but I'll try. In fact, to do it right now so that you get the control flows. Okay. So you see the full architecture here. Okay, this is the point I was trying to make earlier about sharing with other clients. that in GIPC, if I send a proxy to the server, if from this object you get a proxy in the server, and can you send the proxy to the client or not, not the client or not, okay? And that's just not allowed, okay? Because the connections, there is no port that this client is listening to, okay? So there is really this reference has a reference to this guy, and so this makes no sense in GIPC, okay? Whereas in RMI, no direct connection between clients. In input ports, in session ports, we have ways to overcome that. In RMI, I get a proxy here. Now, if I send a proxy back here, that proxy can access here, because only exported objects can be communicated as parameters, and exporting really makes this guy a server port. Every time you do an export, you become a server port. You register a socket at that point. You listen to events from there. So anybody in the world can go and call you.
Server ports are, okay, so that's not, sorry, so proxy.
Right? So whenever you do an export, you are saying, I'm going to listen on a socket connection.
Because the object belongs to me.
Whereas in GIPC, and to be very honest, when I first started using RMI, I thought it worked like GIPC. I didn't ever imagine that the client was also exporting and creating a source. But not, that's why I always forget to export. Yeah.
So then there's a lot of overhead because you have to keep establishing connections and pairing them down.
But then you have this. I mean, there's always trade-off, right?
Right.
You can pass proxies around,
That's true.
right? So exporting an object creates a proxy and creates a GIPC-like server port if such a port has not already been created. That's my understanding of what happens in RMI. Okay, now let's just talk about a few other things here that are related. So let's go and talk about transferring proxies between a client and a server. We know that we can't transfer proxies among clients. Let's talk about clients and servers. Let's assume that this is a duplex port, this is a group port. Okay, can I send a proxy here back to this place? Does it make sense to send a proxy from here to here? I am a proxy, and I have, which must mean that I am calling methods in here. The remote object exists here, right? So if I send it a proxy, does that make logical sense?
Proxy of what?
So I got a proxy here somehow, and I'm the client.
It's not of you. It's some other proxy.
It's either of me or of this guy,
Okay.
right? The only two possibilities.
Right.
If it's of me, can I send it to this guy? It's a duplex port. If it's of that guy, can I send it back to that guy?
Why not?
Why not? And I'll translate it back to the remote object. Okay. If I have a proxy here, can I send it back to this guy?
As long as it's of him or yourself.
Same reason. It's a duplex port. Right? Okay. Surely all the answers are not yes, otherwise I wouldn't go through this exercise. Can I send a reply proxy to this guy?
Seems like it would be a bad idea.
What does it even mean?
Yeah, what does that mean?
Because if you sent it with the client,
That mean-
the client would reply to itself.
So
That's meaningless.
So this is asymmetry here. Okay, and group others proxy and all proxy, can I send it to this guy? It doesn't make sense. Logically, it doesn't make sense. We can probably create some semantics that makes it, but this is a group port. This guy has got many connections. This guy's got only one connection. Okay, so we just understand proxies a little better through this.